So geometry uses variables, numbers, and operations, and you can use the properties of algebra on those variables, numbers, and operations, right? You must convert the congruent shapes to equal measures using the definition of congruence as your reason before you can apply algebraic properties to numbers. This is very important. So now we have a geometric proof where we're talking about the line segment, not the measure of the line segment. Right? When we're talking about the measure of the line segment, we can go ahead and use the equal sign, right? Measure of line segment AB is equal to the measure of line segment CD, because measurements are just numbers. You can say equal, you can use the equals operator. But here we're saying line segment, we're saying this segment in the figure, right? And we're saying line segment QS, not measure. We're saying the line segment, we're saying the drawing in the figure, right? And so when we're saying line segment, we need to use congruent. Is congruent with the line segment QS in the figure. So here, that's congruent with that. And QS is congruent with ST. Again, congruent there, right? We're talking about that figure. We need to use congruent. But we want to prove that the measure of PQ is equal to the measure of ST. So how do we go from line segment to measure of the line segment? Well, this is going to let us do it. The definition of congruence. Okay, let me show you how it's done. Our first statement here is always going to be the given. So we're going to say PQ, or line segment PQ, is congruent with line segment QS, and line segment QS is congruent with line segment ST. And the reason here is given. Now we want to go from line segments to measures, right? So I'm going to go and say measure of line segment PQ is equal to measure of line segment QS, and the measure of line segment QS is equal to the measure of line segment ST. Now what's going to be my reason for this one? It's going to be the definition of congruence. Okay, so to get from congruent to measures being equal, we use definition of congruence. And we can shorten it up by saying def of congruence. Alright, so now what are we supposed to do? We're supposed to prove that the measure of PQ is equal to the measure of ST. PQ is equal to ST. Now, which of our algebraic properties is going to let us do that? Right? Well, it's good old transitive property. If A is equal to B is equal to C, then we can say that A is equal to C. Right? So I'm going to go ahead and put that here. Measure of PQ is equal to measure of ST, and the reason here is going to be the transitive property. And we're done. Right? So what's the key here is that when we have congruent figures in the drawing, we can go from congruent figures to congruent measures using definition of congruence, and then from there we can apply our algebraic properties to the measures.